Hello guys, and welcome back to my YouTube channel. It's me, Afraz, the Knowledge Man, back with another video. In today's video, we are going to be talking about sequences and series. So the first question is, what is a sequence? A sequence is an ordered list of numbers. Pretty simple. A sequence is an ordered list of numbers. There you go. For example, 1, 3, 5, 7, 9, or 7, 6, 5, 4, going on and on, or 5, 10, 15, 20, say going on till 1000, or 3, 6, 12, 24, going on and on, etc., etc. We name sequences using lowercase letters from the English alphabet, and they're totally random. It's your choice. So you can name this first one A, you can name the second one Z, third one E, and fourth one P. Totally doesn't matter, it's up to you. When we deal with sequences, we use the variable n, and its value determines the position of a certain number in the sequence. So the first member of a sequence is A1, or actually we denote by AN, and since the value of n determines the term, the position of the term, so the first term it's going to be A1, the second one is going to be A2, this third one is A3, all the way till AN. We just use n as the last term, AN as the last term. Sequences can be finite or infinite or infinite. So, as we can see in our examples, A and E, in A and E we know the last term, it's 9 and 1000. But in Z and P, we do not know the last terms. They're just going on, and they're going on and on forever. So a finite sequence is the sequence in which we know the last term. It doesn't matter if there are a million terms or that it ends at the number 1 billion or something. It does not matter. Even if it's greater than that, it does not matter. But we know the last term. But in the case of Z and P, we don't know the last term. It's just going on and on forever, so it's going on till infinity, and so it's an infinite sequence. So, A and E win the award for being finite, and Z and P win the award for being infinite. Now, another way to understand sequences is to use the concept of a function. Now, I'm pretty sure that most of us actually know about functions, but I just want to review them very quickly. So, functions. A function is an expression of a relationship between two variables, where one variable is dependent and the other variable is independent. And by the way, the dependent variable depends on the value of the independent variable. So let's take a simple expression or relationship. Say y is equal to 2x plus 3. Now, whatever value of x that we put, the value of y will be double of that plus 3. So we can actually write that the function, since y is pretty much the function of x, so we can write the function of x is equal to 2x plus 3. And now if we put the value of x, if we replace the value of x with 1, then we get 2 into 1 plus 3, which is equal to 2 plus 3, which is equal to 5. And if we put 2, it's a function of 2, which is equal to 2 into 2 plus 3. And that's 4 plus 3, which is equal to 7. And for 3, we have 2 into 3 plus 3 is equal to 6 plus 3, which is equal to 9. So now, the values that we replace as x, the values that we're giving x, we can write them in a set which we call the domain of the function. So the domain of function of x is equal to, here we used 1, 2, and 3 as the values of x. So 1, 2, and 3. Oops. 3. Oh no. There you go. And the values that we got for y, or by replacing the value of x as each of the values in the domain, the values that we get, the results 5, 7, and 9, these we put them in a set called the range of the function. So range of fx equals 5, 7, 9. Yeah. And now let's go back over to sequences. I said that sequences can also be understood using the concept of a function. But how? Well, let's take a sequence. Let's take an example. A nice, easy sequence. Say an equals 3n plus 5. Now, over here, n, this is a function, and n is the independent variable. And the value of an depends on the value of n, or the position of an as well, both. So, for the domain of the function, let's take let's simply take 1, 2, 3, and 4. And let's see what we get as a range. So, a1 equals 3 into 1 plus 5, which is equal to 3 plus 5. And we get 8. a2 equals 3 into 2 plus 5, which is equal to 6 plus 5, which is equal to 11. a3 equals 3 into 3 plus 5 equals 9 plus 5 equals 14. And a4 is equal to 3 into 4 plus 5, which is 12 plus 5, which is equal to 17. And so our range of function is equal to 8, 11, 14, and 17.
And the range is the sequence itself.
And that's it for today's video of the introduction to sequences. See you guys in the next video. Peace out. Yes, I did try closing the camera there.